This video is the second video in the photosynthesis review. Talks about what is light, nature of light. First of all, you have to know that light is energy. It's not matter. Light doesn't have any mass, doesn't take up space. So light is a form of energy. We learned about light travels in waves. And the particles of light, what light is made out of, is called photons. So when light from a source, say the sun, moves, it actually travels like this, which is the wave idea. And at the end, the little particle of energy is called a photon of light. We also learned that light's made in two ways. One is nuclear fusion reactions, which is how the sun actually produces light. So inside of the sun, which is a massive ball of matter, it has so much gravitational force pulling inward on it, crushing down on it, that atoms in it, mainly hydrogen, they can literally have their nuclei squished together. And when they do, we talked about that makes other elements like helium and other combinations, but this fusion of the nucleus of an atom is actually emits or releases photons of light. So light is made by the sun in nuclear, because it's the nucleus of the atom involved, fusion, because they're getting squished together, reactions, and the reaction that makes light energy comes out. The other type of way light is made happens in the sun, but also happens using electricity and light bulbs and whatnot. It's called electron excitation, because if you zoom into one atom, so here's the nucleus of an atom, here's an orbital where electrons orbit the atom, and let's say I have an electron here, I'll put E for electron. If electricity in a wire or something has also electrons passing through it, some of the energy that they have can be transferred to the atoms, the electrons of the atom in the light bulb wire, say, and it can absorb that energy. And when that electron absorbs the energy, it moves to an outer orbital, momentarily storing that energy. But because that's not stable, what happens is that electron ends up falling back to its original position, falling back down, and when it does that, it releases the energy that it was storing as light. Photons of light. So those are the two ways that light can be produced. We talked about that all the different types of energy that's produced by the sun, all the different types of light energy, they vary in wavelength, from really big to really small and everything in between. Smallest being gamma rays, the longest being radio waves. But the electromagnetic spectrum is just the chart or the range of different energies that can be released by the sun. Dealing with this, plants absorb some of these energies here, and molecules in general that can absorb light energy are called pigments. Molecules that can absorb the most important pigment for our unit is chlorophyll. Chlorophyll is the molecule inside of plants that actually captures some of the light energy of the sun. It's green looking, as we've learned, because it absorbs all the wavelengths but green. The idea of an absorption spectrum is a graph that shows what wavelengths of light a pigment, in this case the chlorophyll pigment, absorb the best. So in plants, the chlorophyll pigments absorb violet and blue pretty good, and that green hardly at all, a little yellow, a little orange, and a good amount of red. And so if you kind of trace that pattern, it looks like this. But since it doesn't absorb in the green and yellow area, it reflects that energy, and the reflected hits our eye, and that's what we see. So plants, that's an eyeball. Plants look green because they don't absorb that color, or yellow-greenish because they don't absorb that color. For the next one here, why is something a color? It's a color because it does not absorb the color that we see. So if something looks blue, all the light hits that pigment, but blue isn't absorbed. It bounces off and hits you in the eye. If something's yellow, all the light hits it. Yellow bounces off because it's not absorbed. If something's black, everything's absorbed. If something is white, when the light rays hit it. Nothing's resorbed. It's all reflected. That's what white is. So that's kind of how different pigments work. So, this is just kind of a funny question. If plants were perfectly adapted to absorb all the light that hit them, you probably can assume from what we just talked about that they would be absorbing all of the energy, nothing would be bouncing back, and they would end up looking black. Finally, fall colors, when leaves change colors in the fall. Inside of their leaves, if you can make this out, I have little green pigments, chlorophyll, and little yellow ones. When the plant starts to shed its leaves for the winter, it cuts off water supply to them and the leaves start to die. It turns out that the green chlorophyll molecules start to decompose first. So the green kind of goes away, and that reveals the pigments that have always been there, the ones that reflect more yellow, and so the leaf starts looking a little bit yellow. So it goes green from yellow as the chlorophyll molecules break down as the leaf is dying. The yellow ones last a little bit longer. That's it.